We're still doing this problem. We're finding the point of intersection using another method called elimination. Now, although the previous ways of solving the x and y values for this system is valid, this elimination technique can be nicer and easier, especially when we're dealing with very nice numbers such as 2 and 3 and non-decimal numbers. Let's see how this works. The idea is that we have equation number 1, equation number 2, and we want to somehow eliminate one of the variables. So let's try this in different ways. First, I want to try to eliminate variable x. When I compare equation 2, which has a negative 3x, and equation number 1, which has a positive 1x, what I want to do here to eliminate the x's is to multiply this entire equation number 1 by 3. Let's see what happens here. Equation number 1 times 3, you're multiplying left side and right side by 3, which is allowed because the equality holds true. What ends up happening is we get 6y plus 3x equals 9. Equation number 2, we're just going to leave it alone. Y minus 3x equals 1. We're going to draw this nice old school line and have a giant plus sign here. It's like we're adding this. So when we add these, we're going to add downwards. 6y plus 1y is 7y. Positive 3x added with negative 3x ends up being nothing, plus 0, which I'm not going to bother writing, is equals to 9 plus 1, which is 10. You can see that this is very clean and beautiful. 7y equals 10, therefore y equals 10 over 7 when you divide both sides by 7. And here's your y value. Once we have this y value, in the same way that we used algebra in the past, we can plug it into either equation number 2 here or equation number 1 here. It's fine. So using this elimination technique, what we did here is we eliminated variable x. Let's try the same problem again, eliminating variable y. So to eliminate variable y, and I can do so because these numbers are nice whole numbers that are easy to work with, I'm going to try to make them work out to a nice number. So the number I'm seeing is 2, because what I have here is 2y and a 1y. So let's try that. What we're going to do here is we're going to copy down equation number 1. We have 2y plus x equals 3. And equation number 2, I'm going to double it. Equation number 2 times 2 becomes 2y minus 6x equals 2. And I have this big line here, this big cash register line, and I'm going to go cha-ching, I'm going to subtract. So the idea is this top line subtract the bottom line. So mentally I have to be careful, because 2y minus positive 2y ends up being 0, which I'm not going to bother writing. So don't accidentally write down 4y, because we're going to take the top equation minus the subtracting operator. 2y minus 2y becomes nothing. Positive x minus negative 6x, which becomes a plus x, because remember, two negatives become a positive. If I were to write it all out, it'd be x minus negative 6x, because we're taking the top minus the negative. So this minus bracket minus becomes a plus here. So mentally, let's be careful. X plus 6x becomes 7x. And then this becomes 3 minus 2, because we're taking the top equation minus the bottom equation, becomes a 1. So you can see that dividing both sides by 7, we get x equals 1 over 7. And of course, we can take this value and plug it in either here, or you can even plug it in here to solve for y. Let's take a look at one more example involving this elimination technique. So what we want to do is we want to solve this system of linear equations using elimination. Now this elimination technique, sometimes we have to use the idea of the LCM. So what am I going to do with equation number 1 and 2 to eliminate x, for example? And we can eliminate either x or y. But focusing on x, I'm going to be looking at the number 2 and the number 3. The only way I can cancel these out is if they have the same number. So the number I'm thinking about is the LCM, the lowest common multiple, also called the lowest common denominator. What number is small? The smallest number that 2 and 3 can fit into. And the number that comes to mind is 6. 2 can fit into 6, 3 can fit into 6. So I want to make this into a 6. I'm going to take equation 1 and multiply it by 3. So we get 6x minus, we're multiplying by 3, minus 3y becomes minus 9y, is equals to 15. 5 times 3 is 15. Equation number 2, I want this to be a 6. So we're multiplying the entire left side and right side of the equation by 2. 3x times 2 is 6x. Positive 5y times 2 becomes positive 10y. And 10 times 2 is 20. You can see by using the LCM, we can easily make the coefficients of one variable the same. And here what I'm going to do is I'm going to subtract. And the interesting thing here is you can subtract either top minus bottom or even bottom minus top. It doesn't really matter, it's the same. It's going to stick with convention and go top minus bottom. 6x minus 6x disappears, becomes 0, which is nothing. I'm not going to bother writing it. We have negative 9y minus 10y is going to be minus 19y. So be careful, we have a negative 9y minus a positive value, which becomes negative 9y minus 10y becomes negative 19y, is equals to 15 minus 20, which becomes negative 5. So what we're going to do is we're going to divide both sides by negative 19. We get y equals negative 5 over negative 19, which is the same thing as 5 over 19. Let's try the same idea, subtracting bottom minus top. We're allowed to do that. And let's see how that works here. We could say 6x minus 6x disappears. 10y minus negative 9y becomes 10y plus 9y, which is 19y, is equals to 20 minus 15, which becomes 5. So y dividing both sides by 19 becomes 5 over 19. Excellent. Same result. Mentally going backwards might be a bit confusing. Could save you some headaches too, but let's not worry about that. So let's finish off this elimination example by working with the y's. We want to eliminate the y's. We don't have to eliminate the x's, we can also eliminate the y's. So I'm going to focus on the numbers 3 and 5. What's the LCM? I'm thinking number 15. You can always multiply them as well. 3 times 5 is 15. And so what do I do to equation number 1 to make this 3y into a 15? I'm going to take equation number 1 and multiply it by 5. So 2x times 5 becomes 10x. Negative 3y times 5 becomes negative 15y. And 5 times 5 becomes 25. Equation number 2. How do I make the 5y into a 15? I'm going to times by 3. 3x times 3 becomes 9x. Positive 5y times 3 becomes positive 15y. And then finally, 10 times 3 becomes 30. Focusing on the y's, I see there's a minus 15y, there's a plus 15y. When these have opposite signs, you're just going to add. So adding top and bottom equations, 10x plus 9x is 19x. Adding this negative 15y with the positive 15y's, these cancel out and disappears, becomes plus 0. Equals, adding these, we get 55. Dividing both sides by 19, we get x is equals to 55 over 19. And of course, we can take this x value and plug it into either equation here or equation 2 here to solve for the other y variable. Great job, you now know many ways to find the point of intersection, also called a solution. Stick with what you're good at, and ultimately, I would use the elimination method whenever the problems are dealing with whole numbers that are quite simple. Could be actually faster and easier. Because by using the elimination method, generally we don't deal with as many nasty fraction type problems.